Hello everyone, my name is Homa Samin and I am doing my PhD in computer science from Aston University, UK. I'm also a member of the software engineering at Aston Research Group. And today I'm going to present um, the RDM SIM, which is a remote data mirroring example for evaluation and comparison of decision-making techniques for self-adaptation. First of all, let us have an introduction of remote data mirroring. It is a disaster recovery technique used to protect data by storing multiple copies or replicas on physically remote servers. It also tolerates failures by requesting or rebuilding the lost or damaged data samples from another active mirror to facilitate data recovery. Next, why remote data mirroring simulator? There have been considerable research efforts that have targeted the domain of remote data mirroring, therefore comparisons between techniques are needed. Another point is that RDM applications are very costly to implement as the equipment used to install such applications is very expensive. And there is no exemplar available to support research based on the RDM paradigm. For example, there are a number of existing examples such as Hogna, Deco, CrowdNav, Rainbow, or Delta IoT that focus on different domains like cloud environment, cyber physical systems, traffic management system, or IoT-based system. But none of them specifically focus on the remote data mirroring paradigm or domain. So next, we are going to present the operational model for the RDM SIM simulator. As the main task or goal of the remote data mirroring application or system is to copy data remotely and distribute it by switching between different topological configurations. For RDM SIM, we have selected two topologies, that is minimum spanning tree topology and redundant topology. And these topologies have an effect on the different quality objectives such as minimization of cost, maximization of performance, and maximization of reliability. MST topology supports the minimization of cost and maximization of performance, whereas it has a negative impact on the maximization of reliability. Whereas redundant topology supports the satisfaction of minimization of operational cost and redundant topology has a negative impact on the satisfaction of minimization of operational cost and maximization of performance, whereas it has a positive impact on the satisfaction of maximization of reliability. And these three quality objectives are measured using a number of active links, bandwidth consumption, and time to write data. The RDM SIM architecture is actually used to facilitate a two-layered architecture for self-adaptive remote data mirroring system, uh, in which we have a managing system which is based on the monitor, analyze, plan, and execute MAPE feedback loop. Uh, on top of the managed system, which is RDM SIM in our case. The managing system based on the feedback loop, which is actually architectural blueprint for the self-adaptive applications, typically make use of different intelligent algorithms to perform decisions for the managed system. Our RDM SIM, which is the simulator that we present, is based on the following, mainly three components, that is the management component, network component, and simulation component. This management component acts as a bridge between the managing system and other internal components of RDM SIM simulator. This management component contains the components of probes and effectors that are used for interactions between the managing system. For example, using the probes, the managing system can monitor the information about the different monitorable metrics, whereas using the effectors, the decision is executed on the managed system, that is RDM SIM. Whereas the network component actually is used to implement all the physical elements for the RDM SIM network. For example, number of mirrors, number of active links, the monitorable metrics, and the topological configurations. Whereas the simulation component is used to set up the simulation environment and the simulation properties, for example, the number of simulation time steps, the different uncertain environmental conditions that represent the different dynamic conditions or environments for the RDM SIM network. Following is the partial class diagram for the RDM-SIM simulator, where the management component is composed of the network management, probe, and effector classes, and the probe and effector methods are used by the managing system to communicate with the RDM-SIM simulator. Whereas the network properties, topology list, topology, and monitorable classes are part of the network component, and the simulation properties and uncertainty scenario classes are part of the simulation component of the simulation component of the RDM-SIM simulator. As part of RDM-SIM, we have also defined different uncertainty scenarios that represent different dynamic environments. For example, there is a default scenario known as S0 that represents an environment envisioned by the requirements experts. And over here, the average satisfaction levels of all the quality objectives should meet the required threshold constraints. Whereas under uncertainty scenario S1, unexpected packet loss during MST topology is introduced by switching off the different network links that affects the reliability of the system. Whereas uncertainty scenario S2 represents unexpected packet loss during RT topology to affect the operational cost and performance of the system. Scenario S3 is the simultaneous occurrence of scenario S1 and S2, whereas scenario S4 represents MST topology execution failures. That is, it is the combination of scenario S1, but during the execution of MST topology, it also introduces disturbance levels to affect the operational cost and performance. Whereas scenario S5 represents RT topology execution failures, which is actually a combination of scenario S2, but also disturbance levels are introduced to affect the reliability of the system along with the performance and operational cost. And scenario S6 represents significant site failure, which is a combination of scenario S4 and S5. Next, we are going to present the demonstration video for RDM-SIM. Welcome to the demonstration video for the RDM-SIM simulator. Once the RDM-SIM simulator is installed, we'll have RDM network project in the Eclipse simulator, in the Eclipse IDE. So in order to execute the RDM-SIM simulator, we'll have to set up the configuration settings. For example, we can set up the simulation time steps. Suppose I want to run it for 100 simulation time steps. We can set up the number of mirrors. It is 25 at the moment, and it will create a fully connected network of 300 network links. The satisfaction threshold for the three attributes, the percentage active links for under MST and RT topology execution, and the current uncertainty scenario, and the different disturbance levels that you want to introduce under the execution of different uncertainty scenarios. So for example, if at the moment I want to execute the current uncertainty scenario of 0, that is the default scenario, so let's execute it. Over here, the average satisfaction levels of all the three quality objectives will be meeting the satisfaction thresholds. So for example, reliability is above the satisfaction threshold, whereas performance and cost are below the satisfaction threshold. So let's execute it for uncertainty scenario 1, where disturbance levels are introduced during MST topology to affect the reliability of the system. So under uncertainty scenario 1, the reliability will be below the satisfaction threshold at most of the time steps, whereas operational cost and performance will be satisfied. Whereas if I execute it for uncertainty scenario 2, where disturbance levels are introduced to affect the cost and performance of the system, so these two quality objectives will be above the satisfaction threshold that is not satisfied, whereas reliability will be satisfied. Thank you for watching. Thank you.